are going to explain about a project titled Comparative Study of Machine Learning Algorithms for Portuguese Bank Data. In this project, a journey into the world of machine learning through a comparative study of support vector machine, Gaussian naive-Bayes, and of many more algorithms. In this exciting project, we explored the predictive capability of these diverse algorithms on the range of data sets, seeking to unravel their strength and weakness in handling the real-world scenario. Through the rigorous visualization and the data experimentation, we aim to identify the most approximate and we aim to identify the comparative analysis will empower the data scientists and decision makers to make the informed choices when applying the machine learning in the various domains of healthcare and of banking data. The objective of this project is to conduct a thorough study of four powerful machine learning algorithms of SVM, Gaussian naive-Bayes, random forest, light GPM, and XGBoost on the diverse data sets. By analyzing the performance across the various domains, including the banking, we aim to identify the most suitable algorithm for this. Through the rigorous evaluation, feature selection, and model training, we seek to uncover the strength and weakness of these algorithms, allowing the data scientists and the decision makers to make the informed choice when deploying the machine learning solution. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the project, these are the steps we need to discuss. The first one is importing the library. In this step, essential Python libraries like Pandas, NumPy, sklearn, Matplotlib, Cbun, Flask are imported. And the second one is importing the dataset. The Portuguese bank data containing the features such as age, job, marital status, education, credit, balance, housing loan, personal loan, contact, lost contact month, contact day, lost contact duration, and of many more. And the third one is data visualization. Data visualization techniques such as bar plot, histogram, scatter plots, and correlation matrices are employed to gain insight into the distribution and the relationship between the features. Visualization aids in understanding the data pattern, identifying the outlier, and selecting the relevant feature for the model building. And the next step is feature selection. Feature selection technique like correlation, mutual information, or recursive feature elimination are used to identify and select the most relevant features that contribute to the significantly to the predicting task. And the label encoding is the categorical variables in the data set such as job, marital status, and of more are encoded into the numerical values using the technique like of label encoding. And the various algorithms are used, and the first one is SVM. SVM stands for Support Vector Machine, is a powerful and versatile supervised learning algorithm used for both the classification as well as of regression tasks. SVM aims to find the hyperplane that separate the data points of different classes in the high-dimensional feature space. It handles the linear and the non-linear classification problem by using the kernel function to transform the data into the higher dimensional space. And the next one is Gaussian naive-Bayes. It is a probabilistic classification algorithm based on the Bayes theorem with the assumption of feature independence and a Gaussian distribution for the continuous feature. Despite its simplistic assumption, naive-Bayes perform well in many real-world applications, especially in the test classification task. It is computationally efficient, requires the fewer training data, and is relatively less prone to the overfitting. It is particularly suitable for the situations with the high dimensional and the sparse data where the independence assumption hold approximately. And the third one is random forest. It is a popular ensemble learning method that combines the multiple decision trees during the training process. Each tree is trained on a randomly selected subset of training data and the features, resulting in a diversified set of peak learners. The final prediction is made by aggregating the prediction of all individual trees through the voting for the classification task or averaging the regression task. Random forest is robust, handles the non-linearity well, and can handle the large data set with the high dimensionality. And the next one is Light GPM. Light GPM stands for Gradient Boosting Mission, is a high-performance gradient boosting algorithm that aims to improve the efficiency and reduce the memory usage compared to the gradient boosting implementation. It uses a histogram-based approach for the data binding and employs the leaf-wise tree growth, leading to the faster training times and the better accuracy. Light GBM is suitable for the large dataset and the high dimensional feature space. It is widely used in the machine learning competition and the real-world application due to its speed, scalability, and the ability to handle the complex data structures effectively. And the last one is XGBoost. XGBoost stands for Extreme Gradient Boosting, is another powerful gradient boosting algorithm known for its exceptional predictive performance and the efficiency. Similar to the light GPM, XGBoost uses the boosting where the weak learners are sequentially added to the model to correct the errors of the previous iterations. XGBoost employs a regularized objective function and performs the split finding in a depth-first manner, making it computationally efficient and less prone to the overfitting. And the next step is comparison graph. A comparison graph is plotted showcasing the performance metric of each algorithm. The graph visually represents the accuracy, precision, recall, other relevant evaluation metrics, enabling the easy comparison and identification of the most effective algorithm. And the next step is training the model. The algorithms are trained using the pre-processed data to learn the underlying pattern and the relationship between the features and the target variable. And the next step is user gives the input. The Flask web application is developed to allow the user to input the data for the prediction. Users provide the input for the features through the user-friendly interface. And the next step is the given input is pre-processed for prediction. The user input is pre-processed to ensure it aligns with the format used during the training. Pre-processing includes handling the missing values, scaling, and encoding the categorical variable. And the next step is trained model is used for the prediction. The pre-processed input is fed into the trained model where each algorithm predicts the likelihood of the user subscribing to the service based on the input data. And the last one is final outcome as displayed. And the prediction from all the algorithms are collected and displayed to the user. This final outcome provides insight into whether the contains the deposit or not in the Portuguese bank. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the bank marketing dataset that we used in this project, and the static folder containing of folders, CSS, fonts, images, and JavaScript files within it, and the template folder containing of the HTML documents. It typically include of home, index, results, sign-in, and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And this is the IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And model is a pickle file which likely contains the algorithm information and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operation. And the signup.db is a database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command cd space and paste this code folder path. By this it will change the country directory to the code folder's path. And then write a command that is python space app.p1. By using this command, it will execute the Python script and perform the runtime checks for any syntax errors or the logical issues. and then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see this of some web page, home page containing of it, and click on the sign up button. It will redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. At sign in button, it redirected to the sign in page and containing of the username and password and need to be filled with it. And then click on the sign in button. Here it will redirect it to this index file containing of the input details that are need to be filled. And I am entering those details of last contact duration is of 1475 and the contact is of 2 and the housing loan is of 1 and the P days is of 4 and the previous is of 1 and the P outcome is of 3 and the campaign is of 2 and the personal loan is of 1 and the education is of 1, and then click on the submit button. Here it's shown that of the client did not subscribe to the term deposit. In this way we can find whether the client is having the deposit or not by using this various algorithms, and by pressing the back button and the refresh button. Here we can re-enter the other cases too. I am entering the other case as of last contact duration is of 118 and the contact is of 2 and the housing loan is of 1 and the P days is of -1 and the previous is of 0 and the P outcome is of 3 and the campaign is of 2 and the personal loan is of 0 and the education is of 1, and then click on the submit button. Here the page is redirected and it shows that the client subscribed to a term deposit. And this is the comparison graph where the x-axis represents the algorithms we used in this project and the y-axis represents of the score of each algorithm, and where each metric represents the each bar, where blue bar represents the accuracy and the orange bar represents the recall and the green bar represents the precision. And in conclusion, our comprehensive comparative study of machine learning algorithms with SVM, Gaussian naive Bayes, random forest, light GPM and XGBoost on the Portuguese Bank Data has provided the valuable insights. Each algorithm performance has rigorously evaluated, revealing their respective strengths and the weakness. The results indicate that with outperformed others in the perform of accuracy and efficiency. Thank you for watching.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.